So now we're going to go over solving inequations. And obviously we've been doing lots of that, and there's not a heck of a lot new here, but I guess we're going to consolidate it all and just look at inequations in general. Basically, all inequations can be solved using two simple steps. And I'm going back to the critical points again. Find those critical points. What are the boundaries of the solution? And you find the boundary of the solution by solving the equation rather than the inequation. And equations are always easier to solve because we don't have to worry about, oh, hang on, do I change the sign and things like that. Then, once we have the critical points, we then just go and test in between them. Because we said that it can't change sign unless it passes through 0 or an asymptote. So it can't change unless it passes through the critical point. So you only need to test one point in the region, and it's got to be true for all points in the region. Let's go right back to basics. All right, linear inequations, that's where we started. Well, again, solve it like a normal equation, but this is the one where we probably still leave the inequality sign in there. And remember, if you multiply or divide by a negative number, then you change the sign. Remember, if you change the sign, you change the sign. Then we moved on to quadratic inequations, and polynomial ones in general for that matter. Something like this. 6 minus 5x minus x squared is greater than 0. So I don't like solving negative quadratics. I don't know what it is about it. I'm factorising it. So I turn it into a positive. But if I change the sign, I change the sign. So it's x squared plus 5x minus 6 is less than 0. So factorise the left-hand side. That's what I'd do if it was an equation. And I get x plus 6, x minus 1. I have my two critical points, negative 6 and positive 1. There's my boundaries. So I now test. Now you can draw the parabola in if you like and ask yourself, when is this parabola always below the axis? Or above the axis if you're looking at the first line. But you can, of course, just test a point. 0 is always the easiest to test. Sub into the original one. 6 is greater than 0. Yes, it is. So I know I'm in between the 2 points. And the thing about quadratic inequations is I know the solution will always be in between the 2 points or on the outside. So I don't actually need to check on the outside. If you are feeling a bit unsure, obviously just sub a number in and make sure of the answer. Right, so our answer is x is in between minus 6 and 1. Absolute value inequations then. So we moved on to those. And remember the definition of an absolute value. Absolute value is either A, when A is positive, or it would be negative A. So that's why we break it up into two new ones. Well, let's look at A and let's look at negative A. So if I had the absolute value of 3x plus 2 is greater than or equal to 1, either A, 3x plus 2 is greater than or equal to 1, or negative A, so the negative of 3x plus 2 is greater than or equal to 1. The first one we get x is greater than or equal to minus a third. The right-hand side, x is less than or equal to negative 1. So I have my two critical points. Negative 1, negative a third. Well, again, I can just test some points. Or in this case, I could look at the answers I got. X is greater than or equal to minus a third. X is less than or equal to negative 1. There's our solutions. Well, the next one we moved on to was pronumerals in the denominator. And as you know, I much prefer to use critical points for this one. It's the same sort of idea. I look at this and say, well, bottom of the fraction can't equal 0. So I know x equals negative 3. Now, solve it like an equation. I get x is minus 13 on 5. Critical points, let's have a look at them. Test a point. Well, let's test 0. Go back to the original. So 2 on 3. 2/3 is less than 5. Yes, it is. So I know 0 is included. It also turns out with these linear ones, because x plus 3 being linear, just like our quadratic one, we usually end up with something that's always in the middle or on the outside. Same sort of thing. Thing also to be careful with these ones, because a lot of people forget the bottom of the fraction can't equal 0. That particular critical point will never be included in the solution. But if this was a less than or equal to, the other critical point would be. Now in this case it's just less than, so it's not. But watch out for that. Now 3 and 4, so absolute value inequations and inequations can be turned into quadratic inequations. So here's the absolute value one. That's what I was just talking about before when we were looking at the OneNote. I look at the original equation and I say, oh, no, I've got no idea. So how can I solve this? Oh, I know. I'll square both sides. You see, I can do that with an absolute value equation because squares are always positive. So are absolute values. So if I square both sides, I get 3x plus 2 squared is greater than or equal to 1. And I solve it like a quadratic inequation from that point. So my critical points are, well, I haven't bothered drawing it there, but the critical points are minus a third and minus 1. And so if we test a point, we do end up with the same solution. It's unusual to do it that way, but theoretically you could. That brings us to these ones, and I know this is the way you guys love doing it, okay, because you end up squaring the denominator. So you do that because you know a square is positive. Therefore, when you multiply by, in this case, x plus 3 squared, you know you're multiplying by a positive number, so the sign doesn't change. So if I multiply both sides by x plus 3 squared, so on the left-hand side, x plus 3 cancels into the x plus 3 squared, I get 2 lots of x plus 3. I'm now going to move everything over. By the way, don't expand out if you're doing it this way. You've got a common factor there of x plus 3. Remember, you're going to end up factorising anyway. So why expand out only to factorise later on? It's already got a common factor, so I'm going to leave it like that, pull out the common factor, and then I'm left with 5x plus 13. And we'd end up with the same solutions as we had before. So yes, those two could be done the same as a quadratic inequation. All right, last bit to talk about is using graphs to solve inequations. Not always a brilliant idea, unless you've got a really accurate graph, of course, because you need to know points of intersection and things like that. And if you're reading off a graph, well, you want to hope that they're whole numbers or something like that, so it's obvious the solution. Remember our inequations, we can always turn them into left-hand side minus right-hand side is greater than 0. So when we did that, what we were basically saying is, if we had a graph, when is the graph of left-hand side minus right-hand side above the line y equals 0? When is above the x-axis? Sure, we didn't do it that way, but that is what we were really solving. So anytime you have function x is greater than g of x, you can use the same idea. When is function x above g of x? So if we have to solve this, absolute value of 5x minus 3 is greater than x plus 2. There's the graph of the two. Now, are they nice, neat answers? Ooh, looks like they're off a little bit. I'm still going to have to solve this like an equation to find those x values. And sure enough, they're not nice, neat whole numbers. I've got x equals 5 on 4 or x equals 1 on 6. So 1 on 6 is obviously the left-hand side one, and 5 on 4 would be the right-hand side there. But now I know what those points are. We're saying, when is the absolute value curve above the line y equals x plus 2? Well, we can see then to the left of that first point of intersection, which we said was 1/6, and to the right of the second point of intersection, which we said was 5 on 4. There's our answer. As I say, not a fantastic way of solving inequations. Usually the only time we do it is when they've actually asked us to do it using the graph. Of course, if it's not a test and you're just doing work, you can always jump online and use a graphing package, and that'll find the point of intersection quite easily for you. So things like Desmos and that actually make this idea a lot more attractive. because you let the computer do the hard work for you. You just got to look at the picture. All right. So 3D and 3E we'll have a look at.